In this video, we shall learn about an electric field. Now we know that any two charged, they will experience a force of attraction or a force of repulsion. If we have a positive and negative, then it be a force of attraction. Both the charges will experience a force of attraction, and if it's a positive and a positive, negative and a negative, they will experience a force of repulsion. Both these charges will experience a force of repulsion. But why do these charges they experience a force? The answer is that if we have a charge, say a positive charge which is at rest, then this charge which is at rest will produce an electric field around its base. So that if you bring another charge, say a negative charge here, this charge will experience a force of attraction, or it will be attracted towards this positive charge. And if you bring another positive charge inside this field, this charge will experience a force of repulsion, or in other words, it will be repelled by this positive charge. And here we have a negative charge which is outside the field. This charge will not experience any force. Okay, so only these two positive and negative charge which are inside the electric field produced by this positive charge at the center, they will experience a force. One is a force of repulsion, and the negative charge will experience a force of attraction. So what is electric field? Electric field is a space around a charge, so that if you bring another charge, that charge will experience a force of attraction or repulsion. So that is how we define an electric field. So if we have a charge which is at rest, and say this charge is a positive charge, then the charge at rest will produce an electric field around it. And if we want to find the strength of the electric field at any point, then we'll have to make use of physical quantity which is called an electric field intensity. Okay, so this electric field intensity is a physical quantity which is used to measure the strength of the electric field. Now there's another quantity which is called an electric potential that also can be used to measure the strength of the electric field at any point. That we shall learn in the chapter 2. Okay, so now we'll learn about this electric field intensity. Now this is a physical quantity, and to define an electric field intensity at any point, we shall bring a positive charge at that point. And this a small positive charge is called a test charge. Okay, now this test charge is very, very small in magnitude. It will not affect the electric field produced by this source charge, right? And the test charge is usually denoted by Q0, and the source charge is denoted by Q, letter Q. So now this test charge, since it is positive, it will experience a force of repulsion. So your electric field intensity at this point where the test charge is being placed may be defined as the force experienced per unit test charge of the test charge placed at that point. And while defining this electric field intensity, the test charge has to be very small so that it will not disturb the electric field produced by the source charge. So the mathematical expression for this one here, we have E is equal to F divided by Q naught, which is the test charge. F is the force experienced by the test charge, Q naught. Since force is a vector quantity, so the electric field can also be represented in vector form as E vector is equal to F vector divided by Q naught. Now, since this test charge is very small, we can also express the electric field intensity in another way, as E is equal to limit of the force per unit test charge as the test charge tends to 0. Now this limit, as the test charge Q naught tends to 0, it shows that the test charge is very small in magnitude. So this is the mathematical expression for the electric field intensity. And this electric field, remember, it's also a vector quantity. It's directed in the direction of the force experienced by the test charge. So now we know what an electric field is and how to define an electric field intensity, or how to measure the strength of the electric field at any point. So now we're going to find out the electric field intensity due to a point charge. Okay, so we consider a point charge, say positive point charge plus Q, and say we want to find the electric field intensity due to this point charge plus Q at point P, which is at a distance R from this point charge plus Q. Now, to find electric field intensity at this point P, we shall bring a positive test charge at this point P. Okay, and this positive test charge will experience a force of repulsion, which is denoted by F. And according to Coulomb's law in vector form, the force experienced by this test charge will be given as F, which is equal to 1 by 4 pi epsilon naught Q naught divided by R square and R cap. And this R cap is a unit vector in the direction of the force. Okay, now this test charge is very small in magnitude. Okay, it will not exert any force on the point charge. Okay, since it's very small in magnitude, it will not exert any force on the point charge. So according to the definition of electric field intensity, how do we define the electric field intensity? So your electric field intensity is defined as E is equal to F divided by Q naught. Now if you put this value of the expression for F in this equation, then we'll have E to be equal to 1 by 4 pi epsilon naught Q naught by R square, then R cap, then divided by 1 by divided by Q naught. Now Q naught and Q naught will get cancelled. So what we left is with 1 by 4 pi epsilon naught Q by R square, then R cap. Now this is the expression for the electric field intensity due to a point charge, and this electric field intensity is a vector quantity, and it is in the direction of the force experienced by the test charge. So here your E, which is the electric field intensity due to point charge, is equal to 1 by 4 pi epsilon naught Q by R square R cap. R cap is in the direction of the force F. So here your E is in the same direction as the force experienced by the test charge. So here we have E, which is equal to 1 by 4 pi epsilon naught q by r square r cap. And in magnitude, you can write this as E is equal to 1 by 4 pi epsilon naught q by r square. This is the expression for the electric field intensity due to point charge in the magnitude only.